Hello, students. We are going to go over 6 examples of separable differential equations. You'll notice there's some similarities. 3 of them came from an in-class quiz, and the other 3 were on a makeup quiz for an excused absence. But we will go over all 6. The first 2 examples on this page I think of as the shorter questions. Well, we will get started here. Okay, so when we go to separate our variables, really the reason we're allowed to do what I'm about to do comes from the chain rule, as we talked about in class. But we multiply by dx, multiply by e to the y. Then we integrate the left with respect to y, integrate the right with respect to x. So I have e to the y equals, well, here I have a 5x. When we integrate, we get 1 over 5 e to the 5x plus c. Now to solve for y, I could just take the natural log of both sides. So y is the natural log of 1 over 5 e to the 5x plus c. Make sure this plus c is on the inside of the log. Next one, well, y prime is dy dx. So I will multiply by y to the 4th. And similarly, multiply by dx. Again, this comes from the chain rule. Okay, so we add a power, divide by the higher power. When we integrate the cosine, we get positive sign. So I have 2 sine x plus, well, we can call it c1. Now, multiply through by 5. I have y to the 5th is 10 sine x plus, I'll call this c. I'm really using here that a constant times c is another constant. Now, final answer, we can take the 5th root of both sides. So y is the 5th root of all of this, 10 sine x plus c. Now, just like with the one above, this plus c is underneath this radical. That is important. Okay. Now, next question. Find the general solution to the separable differential equation, and we're instructed to leave our answer in implicit form. All right. Recall that y prime is dy dx. So multiply by sine y, and then we're going to divide by x and multiply by dx. Now I have everything separated. We can integrate the left with respect to y, integrate the right with respect to x. Okay, we know how to integrate the sign. We get negative cosine. But ask yourself, how do we integrate ln x cubed divided by x dx? Well, this would be substitution. So if we want, we can come to the side. I have plenty of room and integrate this function. We have u is the natural log. Du, well, we take the derivative, 1 over x dx. Well, we have exactly du in our integral, so I can make my little box like this. Now, my integral becomes an integral u cubed du. So we add a power, divide by the higher power plus c, and then we go back to x. So we have ln x to the 4th over 4 plus c. Well, in a way, we have finished the problem. We just put this here. ln x to the 4th over 4 plus c. And we're told to leave our answer in implicit form. So I will leave it like this. Minus cosine y equals ln x to the 4th over 4 plus c. Next one, find the particular solution to the separable differential equation. dy dx is x divided by cube root of y with y of 0 equals 1. Okay, fantastic. So we multiply by the cube root of y. I'm going to go ahead and write that as a power. And then we multiply by dx. We integrate with respect to y, integrate with respect to x. Here we add a power, divide by the higher power. Here we have x squared over 2 plus c. Okay, keep going. Maybe I'll call this C1 because I'm about to multiply through by a constant. So we can multiply both sides of the equation by 4/3. I will have y to the 4/3 equals, well, here I will have 2 over 3 x squared plus c. Now, how do I solve for y? Well, I can just raise both sides to the 3 over 4 power. But I'm not finished here. We want a particular solution. So far we have a wonderful general solution. The next step, we need to use this y of 0 equals 1. Okay, so we know 1 would be evaluate at 0. You see my c is 1. Okay, final answer, y is 2/3 x squared plus 1 to the 3/4 power. Next one, very similar to the last. We want a particular solution of a separable differential equation. How wonderful. Okay, we have 1 over y squared. dy is 1 over x dx. We integrate with respect to y, integrate with respect to x. When we integrate with respect to y, we do not get a natural log. This will be a power rule because this is what we're integrating, y to the minus 2. So I can add a power, divide by the higher power. This will equal ln, absolute value of x, plus c. Now, okay, I'll call it C1 again. Multiply through by a minus sign. We get that 1 over y is c minus ln absolute value of x. How do I solve for y? Well, if 1 over y is this, y itself would be 1 over. Or if you don't trust yourself to do that, what you can do is just multiply both sides of this equation by y and then divide by c minus ln absolute value of x, and you will arrive at this. So as with the last example, we now have a general solution, but we're looking for a particular solution. In particular, the one that satisfies y of e is 1/5. So 1/5 will equal 1 over c minus ln of e. Natural log of e is 1. So I get that c minus 1 equals 5, or c equals 6. Okay, final answer is y equals 1 over 6 minus ln absolute value of x. Last one, general solution to a separable differential equation. Leave your answer in implicit form. We've done one like this, but here's another example. Okay, well, let's multiply both sides by x squared dx. Here we will have e to the y plus 2 dy. Here we will have 3x squared divided by x cubed plus 5 dx. Integrate with respect to y, integrate with respect to x. Okay, well, as I mentioned, there were some similarities because half of these questions were on an class quiz and half of these questions were on a makeup for an excused absence. But nonetheless, on this side, substitution So we can come over here and integrate 3x squared divided by x cubed plus 5 dx. My u, well, is x cubed plus 5 in the denominator. Du is 3x squared dx. You'll notice I have exactly du in my integral. So now I have an integral 1 over u du. We integrate, we have ln absolute value of u plus c, and then we go back to x. ln absolute value x cubed plus 5 plus c. Okay, so we have figured out this integral of x cubed plus 5 plus c. To integrate with respect to y, well, we integrate e to the y, and we integrate 2 dy. So this is my final answer in implicit form. Okay, well, this is the end of our 6 examples with some separable differential equations. Thank you so much.